Should we be coloring our star green to make it stand out for potential aliens? What would it take for a space station to be fully self-sufficient? What happened to LUVOIR, which was supposed to be a bigger version of James Webb? And in our free bonus question on Patreon, can you win a Nobel Prize by watching YouTube videos? All this and more in this week's QA. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. How McKinney, could an Earth orbiting space station be created that is 100% self-sustaining? In theory, sure. You know, when you think about the inputs, the outputs, right? You've got plenty of solar power that's coming to the station. You've got a closed environment where you can recycle the water, the food, all of the things that are coming in the atmosphere, and you should be able to eventually make it self-sustaining. And when you go back to some big experiments that were done here on Earth, the Biosphere 2 project was this example. They were trying to take a place that gets a lot of sunlight and see if you can create a habitat that is closed off from the larger Earth and the thing can be completely self-sustaining. And the answer that they learned was concrete, when it cures, sucks oxygen out of the atmosphere and releases carbon dioxide, and that's bad for the people that are inside of that. And that instead of being open and honest and transparent about the problems that you're having and tweaking the experiment, you keep a tight lip on it, and then it eventually comes out as a scandal and embarrasses the entire project and sets back closed ecosystems for decades. That's right. That's what happened with Biosphere 2. There's some great documentaries about this. I highly recommend that you watch them, because I think the underlying experiment was really important, right? If we want to be a solar system spanning civilization, we've got to learn how to rebuild Earth's ecosystem, its closed environment in other places. And we don't know how to do that. And in fact, by doing that, we will learn more even about what we're doing to planet Earth, all the gases that are building up, all of the things that are needed by the life, help us catch. So I think Biosphere was a critical experiment, but they went about it the wrong way, and they didn't keep going, learning from their mistakes year after year, iterating the way they should have. But there's a lot of other experiments that have been done on Earth that have been attempted. There's a much smaller scaled version that's being done in China called the Lunar Garden. And so it's the same kind of thing where they put a bunch of people into a closed environment, close it up for a year, and see what's happening. They've run several rounds of this. So I think, these experiments are being done. And once we understand all of the inputs, all of the outputs, all of the machinery that's required, everything that breaks down, everything that is required, then you can try to replicate that environment in space, where you can't just open up the window and let the air in if it turns out you don't have enough atmosphere. So step one, master that process here on Earth. Step two, try to continue that process out in space. And then as you figure out, oh, we don't have enough of nitrogen. Okay, let's send another cargo of nitrogen, and then let's tweak the experiment so that it can handle enough nitrogen. Eventually, we will get good at this. Like eventually, after 100 years of us running closed environments on other worlds, we will become masters of replicating the kind of environment that human beings require on other worlds and all the different conditions, lower gravity, out in space, rotating space stations from closer to the sun to out towards the Kuiper Belt. This is what we will eventually be able to do. But, again, maybe not in my lifetime. Robin W. Do we want to turn our star green so we can get noticed, or do we hide and bide our time? So this question is related to the fact that there are no green stars. And that's kind of surprising when you think about the spectra of visible light. You go from, red, yellow, orange, green, blue, violet. And we know that there are red stars, we know that there are yellow stars, and there are orange stars, and there are blue stars, and there are, I don't know if they're violet stars, but there are different shades of blue. But why are there no green stars? And yet, if you actually observe the photons coming from stars, you do get green photons. And yet, when you look at the star, it doesn't look green. And part of it is just that there is this sort of black body curve of radiation that is coming from a star, that it's not just sending you one specific spectrum of photons, it's sending you a whole bunch, some red ones, some blue ones, some green ones, some ones that are more on the, on the blue side. And the average color of the star works out to be whatever is the average color of the photons that are coming your way. And so with stars, even stars that are very hot, you're going to get this average spectrum that you don't get the green. And so in fact, I think the peak of the sun is green, but yet because you have the ones that balance them out, it doesn't look green. It looks yellow or even kind of whitish from our perspective. And so this is an idea that people have proposed, that one techno signature, a way to broadcast your existence to the universe, is that you could put up some kind of filter that would float in front of the star. And then that would block a bunch of the photons and let the green ones through. And then anyone out there who is looking at your star would notice this bizarre green star and know that that was completely artificial, that there are no other examples of green stars. So should we do it? Well, I mean, it is beyond our technological capability to pull something off like that. Is it a good idea? It depends on whether or not you think that broadcasting our existence to the universe is a good idea. Maybe we might want to wait after we've completed a survey of some nearby stars to make sure we know what's out there and who our friends might be and who our enemies might be. But it's a relatively efficient way to put a signal out into the universe that your civilization exists, which is pretty cool. Parker, how can we still see the CMB? If it's not an ongoing event, then how can we still see it? We can't see supernova events forever. You're seeing a different part of the universe every second that goes by. So when you think about it, the light has been traveling from the cosmic microwave background, and it's taken 13.8 billion years to get to us. And you're seeing the photons when they were first released from the universe way back in that time. But a minute later, you're seeing new photons from a new region that is 1 light minute farther away. And they are the ones that are releasing their photons for the first time, and they're making their way across, and those photons are arriving at your eyeballs. And then an hour later, you're seeing another part of the universe that is releasing its photons for the first time, and they're reaching all the way. And so we are always seeing new photons from new regions of the universe where their light has finally been able to reach us. Do you want even more questions? Now, we release the overtime segments every week over on Patreon, in addition to the question shows themselves. And so between the question shows and the overtime segments, you get the full live stream, but it's all got nice B-roll and graphics and more. You can access it as a Patreon member. And so if you want more questions, go to patreon.com/universe today. And thanks to everyone who has already subscribed, and welcome to our recent newcomers: Chip F., Glenn Howell, James T. Watts, James Sheehy, Art Deco, David Riley, Kevin Prince, Dan Becker, Andrew Lowhead, and Dave C. Join our club at patreon.com/universe today. Nathan Myers: should we be demanding that Starlink satellites be made of something that does not catalyze the destruction of the ozone layer? So one of the things that people are concerned about the Starlink satellites is that they re-enter the Earth's atmosphere. And as they do, they burn up, and in theory, this can have an impact on the ozone layer. Also, you've got the launch of satellites. Spacecraft are going to launch, they go through the atmosphere, they go through the troposphere, and they deposit particles into the troposphere. And this is, there's not a way that we can get particles that high up into the atmosphere except with these rocket launches. And so people have done research to see that, okay, yeah, there is some kind of potential environmental impact from us launching these rockets high into the atmosphere. So these are certainly possibilities, and they're not going to have zero effect on planet Earth. But I think it's important to put the scale of what we're doing with satellites and launches against the natural things that are happening, which is that about 100 tons of rocky debris from the universe is entering the Earth's atmosphere every single day. And that is several orders of magnitude more than the amount of human-built spacecraft that are returning through the Earth's atmosphere. So it's having an incremental effect on the planet, but it is not anywhere near the scale of what's happening naturally. The amount of rockets that are launched every year, although it is growing and it's more than it's ever been, it's still a fraction of the amount of carbon dioxide emissions and methane emissions and all that produced by humanity's industrial process. And so these are classic examples of things where, when you go back and look at the presentations made by researchers during the 80s, 70s, talking about the future, 30s, talking about the future of humanity's impact on the global atmosphere and what our rising carbon dioxide emissions are going to do. They're saying, like, here's this thing that we do. When we do the math, it's going to have an impact down the road on our atmosphere. It's going to cause increased warming around the planet. We should probably figure out what we're going to do about that before we have to suffer the consequences of that situation. And so this is the same kind of thing, which is that you see these satellites, they're re-entering the Earth's atmosphere, they are releasing particles into the atmosphere, and we are contributing to the natural effect of what those things are going to be able to do. And it is just a tiny fraction today, but you can imagine it growing into the future. And there's a lot of great solutions to this. Like right now, we launch a lot of rockets, but instead of launching rockets, what if we transitioned into a civilization that does a lot of in situ space resource utilization, where we use asteroids or stuff from the moon to be able to create things. We don't have to launch rockets. We just have factories in space that are building things. Now we don't have to worry about the global warming effects. What if we organize the orbits of satellites so that they don't have to run into each other, in the same way that we have airplanes that fly on very specific flight corridors, that we have boats that transmit cargo along very defined shipping lanes? There's room in space to do this. You just have to have an international group come together and agree that this is where we send satellites that are going to be observing in this region, and this is where we send them in that region, and you can sort of do that. And then you can change the orbit, the altitudes of the spacecraft for the one that is like the perfect match between, lifetime of the satellite and the kind of work that needs to be done. And that you could put some kind of kick stage on your satellite so that when it's finished the end of its life, maybe it kicks itself into a higher orbit, a safer orbit, that both doesn't enter the Earth's atmosphere, but also maybe makes it usable by future civilizations who want to be able to use the metals that's already been put into space. So, this is just a classic example of the tragedy of the commons, that we are moving forward, we are aware of the downside, and we don't think it's going to be a problem, and so we're just going to keep going for it. And as always, it's future generations that have to pay the price. Hussein Studio. Any updates on the LUVOIR telescope? Now that we've got the Hubble Space Telescope and the James Webb Space Telescope, astronomers wanted to think about what was going to come after. What were the next big observatories? And so they put out a bunch of proposals for 4 great observatories that would follow on to James Webb. And one of those was called LUVOIR, the Large Ultraviolet Infrared Optical Observatory, is how that all adds up. And so this would be a bigger version of Hubble, probably like a 12 to 15 to maybe even 20 meter telescope, but in space, capable of doing the same kinds of observations that Hubble does. And the same kind of specialization as Hubble, which is, very small field of view, something that can look at individual targets with really high resolution. And then in 2020, they did what's called the Decadal Survey, where all of the astronomers come together and they agree upon their priorities. And one of the priorities was to build this next generation telescope, but they were worried about all of the cost overruns that had happened with the James Webb Space Telescope. And so they merged a bunch of these telescope ideas together and scaled down the size that they were expecting to want to be able to produce. The one that got them the ability to observe the atmospheres of Earth-sized worlds orbiting around sun-like stars, but kind of no more. The bare minimum. And so this new version of it is called the Habitable Worlds Observatory. And so it's going to be a 6.5 meter telescope, very similar to James Webb, but it's going to have a different area of the spectra that it can observe in. And it should be capable of directly observing these Earth-sized worlds orbiting around sun-like stars. And what will make this possible is that it will have a coronagraph on board that will block the light from the star, revealing fainter objects that are around it. It will also probably launch with a sun shield, which will sort of float in front of the targeted star, and then that will also help reveal the planets that are just nearby. Like, it's going to be 10,000 kilometers away from the telescope. And, they're still in the initial phases. We're reporting on every single incremental improvement at Universe Today because I can't get enough of this telescope. But it's probably not going to launch until the late 2030s or even into the 2040s. So what happened to the Origins telescope? What happened to the HabEx, the Habitable Worlds Explorer? What happened to the HabEx, LUVOIR, Origins? They've all been mashed into this one telescope that's going to be a little smaller, probably launching in the 2030s or 2040s. But remember the cuts to the Science Directorate. This would be the kind of thing that would be developed by NASA's Science Directorate. And so if they follow through and cut the funding, then this is the kind of thing that would probably have to either get canceled or just pushed out into infinity. In other news, China is planning on launching their the Chinese Space Station telescope in 2 years, and this is going to be their version of the Hubble Space Telescope, and it's pretty cool. So I think, if the US doesn't want to continue building the Habitable Worlds Observatory, there's a lot of other nations. The Europeans are planning their LIFE telescope, the Large Interferometer for Exoplanets, and that will also be capable of observing Earth-sized worlds orbiting around sun-like stars. And then there is similar work in China to develop the same kind of telescope. That they've made observing Earth-sized exoplanets a high priority for their science objectives. And so we don't know what's going to happen with the HWO, but I think there will be that capability coming from other nations no matter what. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And this week's bonus question is whether you can win a Nobel Prize just by watching YouTube videos. All right, those are all the questions that we had this week. Thank you everyone who asked questions both in the YouTube comments as well as in the live show, which is the 2-hour live stream that we record every Monday right here on the channel. Now, there is going to be a time for when that's going to happen somewhere. I think the next one is Australia time, which will be Sunday night for me. But yeah, there should be an event here and you can just notify yourself when that next event goes live. Now, I'm going to talk about some recent shows that I've been enjoying. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bray Lake Roofing, Brian Body, Caradwin, Chuck Hawkins, Commander Bayluck of the Thesaurus, Cy Nelson, David Giltonen, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Lawrence Federico, Marcel Smits, Michael Purcell, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Spiderswap.io, Stephen Fowler Munley, Thomas L. Skadron, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I've got 2 television shows that I have been watching that get the Fraser-Cain seal of approval. The first, actually both are on Netflix, and the first is called Apple Cider Vinegar. And this is a story about a health blogger from Australia who faked a brain tumor and then used that as the foundation for a giant health marketing company. And over time, it was revealed that she had not actually gotten brain cancer, but her app had gotten onto the Apple iTunes store, that she had sold tons of copies of a book and became the celebrity in Australia. And it's a 6-part series, sort of has a nice beginning and an end, and it's a biopic, and so it sort of like shows a version of the story, which is more or less accurate. But they do a really good job of showing you how these people are really believers, like people who are into alternative medicine, into homeopathy, really think that they're taking their own health under their control and that they are being more healthy than a person who goes and sees a traditional Western medicine doctor who potentially has to get their arm cut off because of cancer. And so I think, you know, for those of you who are watching this, you're all big science fans. And so I think you'll roll your eyes at the things that people believe. But we experience this. We encounter people who, for whatever reason, have fallen under the sway of this sort of, very convincing influencers who are saying that there's a different way beyond the scientific method. And so I think, if there are people in your life who you think might be on this spectrum, you might want to have them watch this show, because it handles the perspective of the people who are under the sway of this with like really delicate, very complex motivation. And it's not just that they're evil and they want to scam people for money, that they really believe this stuff, and sort of what are the kinds of reasons and why. And so I really enjoyed it. So that's Apple Cider Vinegar. The second show that I think you should definitely check out is called Adolescence, and that's also on Netflix. And this is about a murder in the UK where investigators realize that there's more to the story than they thought. And what it really turns into is this really horrifying look at the state of social media and what effect it's having on kids and algorithms, and the way it is turning kids against each other for the clicks and the likes, and how it is just really hard to be an adolescent now in this time. And I'm sure a lot of the people who are watching this right now are either, a parent of a kid who is going through this time, or we have a lot of teen viewers as well. And I know you might be going through this as well. And that so much of this is from these predatory algorithms, these social media algorithms that are just feasting on the sorrow and sadness of kids and people who could be reading books and being outside and spending time with people, and that instead they're being set at each other beyond the kind of traditional bullying that happened when I was that age. So I think it's really interesting to sort of see what kids are up against these days, and to really question, if you use social media, take a second to think about what this is doing to you and how this is distorting your perspective of other human beings and yourself and your own self-worth. I found it really, really good. And like, just technically, the show's amazing. They shoot each episode as one long cut. And so, it's kind of amazing how many times they had to redo the whole thing because someone might have messed up a line later on, or timing didn't work out, or whatever. It's technically amazing and also really compelling watching. So I highly recommend. So the two shows are Apple Cider Vinegar and Adolescence, both on Netflix.